Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Chaiken and Seth's brother Joel. And we're here to hopefully show you how to approach SAT math questions, if not all math questions or a lot of math questions. Here we have question 17 from the sample SAT questions that the SAT people have distributed for the upcoming digital SAT that's coming in the winter of 2024. So here we have question 17, and here we go. Please read it, try it, pause the video, and then come back. The length of a rectangle's diagonal is that thing. Well, we could just draw. We could start drawing, right? Because it's a geometry problem. They don't give us the diagram.
Well, it's a rectangle.
Rectangle's diagonal is
Yeah.
5.
So there's your rectangle.
Thanks. Yep, 5 square root of 17. And the length of the rectangle's shorter side, is 5. What is the rectangle's longer side? So this is a geometry problem. And I always think of geometry problems. Most of the geometry problems, you need to have you need to know the geometric relation that relates the different numbers, the different things in the geometry problem. And if you don't know the geometric relation, then you can't do the problem. So this geometric relation is probably one of the most important geometric relations out there. Seth, do you want to say what the geometric relation is that relates these things?
The Pythagorean theorem.
Right. That's right.
And so let's write the Pythagorean theorem out in this case.
Okay.
5 times the square root of 17, the whole thing squared, equals 5 squared plus x squared. Right. And now what is the length of the longer side? Let's call that x. And you need to find x. So here's an equation for x squared. So you solve for x. And the way you solve for x is first solve for x squared. X squared equals, subtract 5 squared from both sides.
How's Lightboard's behaving today? Very nice response time.
Okay, and you factor out a 5 squared.
Ooh, that's high level math.
And then you get 17 square. 17 square root squared is 17. And then you factor out the 5 squared. That gives a 1. 17 minus 1 is 16. And that's a perfect square.
Right.
Right? And so that equals x squared. So x squared is a perfect square. It's 5 squared times 4 squared, right? So square root is 5 times 4, also known as 20. And so the answer is 20.
Right, so take the square root of those two sides, you get 5 times 4 is 20, right? So SAT comes through again in using patterns and making calculations easy if you're smart and you're observant and you see things like this. Many people, now this is a calculator question because every question on the new math SAT is a calculator question. So some people would actually figure this out. Some people would do 25 times 17 minus 25. Some people would do that in a calculator. Right?
Well, what you could do is plug in if you're dumb, and make your calculator do all your work. You plug in 5 times square root of 17, right? And then tell the calculator to square that, and then subtract 5 squared. And then tell your calculator to take the square root, and it will pop out the answer.
Right. So if you do that, you've got to be really good with your calculator. because you
Yeah,
have to make
yeah,
sure to put everything in parentheses. I mean, you got to be really
yeah.
careful on a calculator. See, people who are going to do this problem, Seth, you should have said that was. I'm gonna
Yeah.
okay. You should have said that. You should have.
Well, that's smart because it could be smart because you get the calculator to do all your work.
Yeah. So then you shouldn't have said that. So I
Yeah, I shouldn't have
apologize
said
from
it.
Seth for saying that.
Yeah,
Okay, that's fine. But anyway, no. But seriously, if you are going to really use the calculator, Seth said, you really got to be careful to get those parentheses right, because you have to
well,
square 5 times the square root of 17.
yeah,
So if you're a calculator person who does that, practice with the calculator. Make sure you get that done right. If you're not a calculator, if you don't do it as much with the calculator, you certainly have to know what the square root of 17 squared is. That is only 17. Um, so yeah,
yeah,
maybe without the calculator, you would. Um, this is 5 times the square root of 17 squared. You would see this is 5 squared, which is 25 times 17, then minus 25.
yeah.
But Seth did it very cleverly by factoring.
Well, yeah. So what I did was I avoided the arithmetic. Avoided the arithmetic until the end, and so I was able to simplify things. Well, here's another clever idea. They tell you the length of the two sides of the triangle, which is the half of the rectangle. Both of them are multiples of 5. So you could scale the whole problem. Scale it down by a factor of 5, and then you have 1 and 17. Sorry, 1 and the square root of 17. So you have a scale triangle whose hypotenuse is the square, whose length of hypotenuse is square root of 17. One side is 1. And what's the other side? Well, it gives the Pythagorean theorem on that easily. Square root of 17 gets 17. Square 1, subtract 1 gets 16. Perfect square. So that's a 4. Now scale it back up. So this triangle 1, 4 square root of 17 is a 1/5 replica in length of the original. So scale the 4 up by the scale factor and get 20, which is the answer.
Which is interesting, because when you did the factoring, that's essentially what the mathematics did.
Yeah.
That's essentially what's going on mathematically. Is
yeah,
sort of, yeah. Oh, yeah.
Yeah.
Okay. But that approach that Seth mentioned, do the arithmetic at the end, is really, really a really important approach. And try to do that on your problems. Is try to leave the final arithmetic calculations to be the end, because you may see that things simplify inside the calculations. Like things really simplified here, didn't they? And on particularly SAT questions, a lot of test questions also, that you're not going to get crazy numbers that require calculus like 23 and 17. You're going to get things that sort of simplify, and you see the simplifications when you leave the final arithmetic at the very end. Yeah. Okay. So why don't we? What's your thoughts, Seth?
Nothing.
Yeah. Okay.
Just thinking that they might give an alternative. Suppose instead of 7 square root of 17, they have the square root of 13. Then the answer would be 5 times some square root number.
Right. Yeah, it would be more
not
like
a perfect, not an integer.
It would be more like that. And of course, you need to know the Pythagorean theorem. If you don't know the Pythagorean theorem, you can't do this problem. You can't do any you can't do most geometry problems without knowing the geometric relation between the different things. We checked before the video to see whether they give you a reference sheet on the sample
Yeah.
questions. They do not give us some on the pamphlet. They did not tell us what the reference sheet's going to be for these sample questions. So for the SAT given now, you get a reference sheet, and I don't know. I don't remember whether the Pythagorean theorem is on the
someday
reference
we'll
sheet.
find out.
But they may have a different reference sheet for this test because this test is going to be different.
Okay. So another fact that you need to know is this was written in blue, that when you have a rectangle, what's a rectangle? Say a quadrilateral where all four angles are 90 degrees.
That's right.
The sides are parallel, orthogonal. And so since each corner is a 90-degree angle, the diagonal together with two adjacent sides forms a right triangle.
You're right. That is absolutely.
So you need to know that the diagonal and the two adjacent sides. I don't know whose angle is opposite the diagonal of a rectangle form a right triangle.
Right.
You have to know the Pythagorean theorem. The Pythagorean theorem applies. So you could think Pythagorean theorem applies in two places. Oh, it's essentially the same. A self-standing right triangle or a rectangle with its diagonal.
Right. Yeah. Okay, presumably people who are taking the SAT have seen this question before in geometry. Whether you've taken geometry with proofs or without proofs, this is standard geometry in the normal high school geometry class.
Yeah.
So my suspicion is that when we're going to reveal the big reveal, the answer the SAT says, my suspicion is that it's going to be a very traditional answer. It's going to say the Pythagorean theorem. It's going to say how to apply the Pythagorean theorem. But it'll be interesting to see whether they actually calculate it out like I did, which is 5 times 25 times 17 minus 25, or they did it Seth's way. They probably did not do it Seth's way. Okay, yeah. B. Oh, wow, Seth, you got it right. Congratulations. Use the Pythagorean theorem. Okay. Okay. To calculate the length of the Pythagorean theorem. Now, oops, we have to move somewhere else. Let's see. Oh, here it is. Yeah. Okay, let's see how they do it. Okay. Okay, which is equivalent to this. Yeah, so they're doing it the normal way. They're doing it the normal way.
Yeah, what a waste.
Yeah. Yeah, well, that was completely expected. Right.
The waste of time to calculate 425. What's 425?
Right, right. But they're assuming everyone has a calculator. Oh, by the way, the calculator on this test, I think you could bring your own, better check. But they definitely, this test is going to be on a computer. They're going to give you a calculator on the computer. Okay, yeah, so this is done the traditional way, not the way Seth did it, where you do the clever factoring. Okay, that's completely expected. Okay, Ron, so then have a great day, and we hope to see you next time we meet, which hopefully will be tomorrow. Okay, everyone. Please like us, dislike us, give us comments on our videos, and email us your SAT math questions at satmathquestionoftheday@gmail.com.
Yeah.
So if you look a little not happy about something.
No, I'm just staring around.
You're just checking things out. You're just making sure they're right. Okay, good.
Yeah.
Okay, everyone. Have a great day then. Bye.
Okay, bye.